Imagine being a customer of a website for booking amazing trips. But it's 2025, right? So you open your favorite LLM chat, your ChatGPT, your Claude AI, or desktop. You quickly authorize your favorite website, and you add a prompt. I want to go to Spain and spend a romantic weekend around the middle of July. Book me a spot in a 5-star hotel. Just make sure the weather is great. Please. You wait a second for the assistant to do its magic, and it's done. You hear a sound of an email message incoming. It's a booking confirmation for your next trip to Barcelona. Well, wouldn't that be amazing? Wouldn't it be even better if the website could run on Ruby on Rails? To make this dream come true, today I'm going to tell you how to make Rails AI ready by design with Model Context Protocol. Hi, I'm Paweł Strzałkowski. By day, I'm the CTO of Visuality, a Ruby agency from Warsaw, Poland. And I've been a web developer for well more than 20 years. But I love adding a creative spark to whatever I do. So for example, last year in Toronto, I've given a lightning talk on Rails World about using Rails as a multiplayer real-time game engine, which was kind of fun. And depending whether your heart lays with code or business, you can find me on GitHub and or LinkedIn. Let's get it on. So let's start with a brief introduction to what Model Context Protocol is in general. So the internet is full of applications, server, websites. Well, you know it. You're the ones who build those, right? On the other hand, we have an explosion of LLM-backed solutions, from online assistance through desktop solutions up until the developer tooling like Cursor or Claude Code. Yet there is a thick wall between LLMs and normal websites. It's because LLMs have no power of accessing the content in the real-life world, in the current world, in the classical applications. So a prompt asking to book a European romantic trip has no chance of succeeding. Because again, LLMs have no access to real-world data. Of course, we can work around. We can build an application which, on one hand, converses with LLM using prompt and response, and on the other hand, uses API endpoints that we all know and love, and just translates it back and forth. And it can be done, and it's done over and over again, and sometimes it is the way to go. However, when you do it on scale, when you do a lot of models and a lot of solutions, you quickly get to something called M times N integration problem, where you have M models and N solutions. And whenever you want to add a model, you have to program it N times, and whenever you want to add a solution, you have to add, again, do it M times. It just adds up very quickly, and it just feels like a wrong tool for the job. Doesn't feel AI native, whatever it means. So in order to make it right, to make it work, a large language model needs to be given real-life current context over an AI native protocol. The only thing, naming is hard, but if model needs to be given context over a protocol, let's call it Model Context Protocol. So what is it? What is MCP? It's an open standard. Open means it can be used by all of you, any of you, and it can be used, implemented by everyone. It has been introduced by Anthropic last year in November, and it was so well accepted that it was backed by Google, OpenAI, and others around the world. There are so many one-liners that say what MCP is none of them is true, none of them is accurate, but allow me to do my attempt. MCP is something that standardizes the way of providing additional context for LLMs. And that additional context means also dynamic, real-world, up-to-date current context. So knowing what MCP is, let's take a look at the architecture of a system using MCP. So the central piece is called MCP host. It's the user-facing application, like your ChatGPT or Claude or Google AI Studio. The host application communicates with LLM using prompts and responses, as we all know and love. On the other hand, MCP servers provide additional context. This context is either provided by over HTTP, which we're going to do today, or if MCP server runs on the same machines as MCP host, it can be provided over a standard input-output, but that's not today's subject. MCP host, the central piece of this architecture, fetches context from MCP servers using MCP clients libraries, and whenever it sends a prompt, the prompt is enriched with the context from MCP servers. We'll do an exercise in a second. So I've said that MCP servers expose context so many times already, but what MCP context is, what this additional context is? Well, context is built of so-called primitives, which in sum, all those primitives add together and form this entire context of a server. And there are a few basic primitives. The first and foremost are the tools. This is what got the attention of people and got them into MCP for the most part. Tools are executable functionalities. Basically, what a server can do for you. So we can, for example, forecast weather for a given location or error date, can list your trips, can publish your article. Whatever the server can do is exposed within tools. The next primitives are resources, basically data, images, logs, entries, files, whatever is needed for this additional context for the LLM. And the last on this list are prompts. So those are standardized instructions which MCP hosts get from the server and shows to the user. So a user can choose a kind of recipe part of conversation. So knowing the primitives and the architecture, let's go over a single use case of MCP interaction between MCP host, LLM, travel agency application, and weather forecast application. So it all starts by enabling the application, right? During initialization, the MCP host fetches MCP primitives from the servers. So first of all, from travel agency MCP server and from the weather forecast MCP server. We get tools, we got resources, and now they are all loaded into host. Here comes user saying, book me a romantic European trip, just make sure the weather is good. So we take that prompt, the MCP host takes that prompt, takes all the tools and maybe resources, and sends to LLM. Now LLM doesn't respond with, I don't know what you mean. Responds with a tool call saying, list romantic trips. This comes back to MCP host, and MCP host asks MCP server, the travel agency one, to list all the trips. Now, with this list of trips, we go back to asking LLM. We take the initial prompt, the initial response from LLM, and the response from the server, and all the tools, and we send it once again to LLM. Now it has additional context. With this additional context, LLM responds with 3 tool calls, requests, for checking weather in 3 different cities at a given date. So MCP host asks the MCP server 3 times for the weather forecast. Having this information, all the initial prompt, the list of the trips, and the weather forecast, we send it once again to LLM, and finally, LLM answers with a tool call for booking actual trip to Barcelona. The example ends here, but can you see the magic already? For me, the ability to control applications using plain language and having LLM doing all the complex multi-step procedure logic is just pure awesome. One additional thing, the LLM within this conversation has short-term memory of whatever it was done before. So how can we build such an AI-ready website? First of all, we need a new age framework, right? So let's use this one. It's as up-to-date as ever. And let's today recreate the most famous Rails application ever. Let's, once again, build the blog engine. But this time, let's also make it AI native and ready. So it all starts with Rails new. It would be the best to have an option within Rails framework just to put it in MCP mode. But we don't need the framework to provide a single recipe. We have templating engine. So I just apply a template which adds a few additional things to the framework. We add the official Ruby SDK for model context protocol. We add additional route. We add additional controller and some application, some configuration. And we'll go over that in just a few slides. So what I applied is this repository. This is a template. It's of course available to you as well, and will be linked within this QR code throughout the presentation on multiple slides. So what it adds of course a route. It adds a controller with a small fix because I needed it for some of the MCP host applications, and a big part of the application that we're gonna build. You know how to build a blog engine, right? You scaffold application record. We're going to do the same. However, what the template does, it additionally scaffold tools as you scaffold application record. So again, I had to extend the scaffold controller generator with some additional templates for the tools. And well, not all tools have to come from scaffolding application record, or even shouldn't. So we have MCP tool generator we're going to use later on as well. So we had Rails new. Now let's start the server. So we start just classical Rails server. Nothing new in here. Let's open it. Yeah, it works. But apart from this, we can run another program. It's called MCP Inspector. Once you start building MCP, you're going to use it for sure. You can validate your server. You just put URL of our new server /MCP. We select the HTTP method of transport, and we hit connect. And guys, we are connected. There are no tools, no prompts, not whatever, but just having our Rails server as MCP server out of the box seems promising. To follow the classic story of the blog application, we should now scaffold posts. So let's do it. Again, almost nothing new in here. We hit Rails, G, scaffold. A post has a title and has probably a body. We run this scaffold, and we can see additional files generated. So we have a tool for each CRUD action. Let's just run the migration. And let's see. There's nothing new in here, right? We just need to create one post for future reference. Once it's ready, let's review scaffolded MCP tools. With the template comes a very simple rake task that lists all the tools defined within Rails. So again, we have a tool for each CRUD action of post. So each tool comes with description and some input schema. We can also see those tools in MCP Inspector. So let's do that. Let's connect once again. And now, if we go to tools and we list them, we can see all the tools available. Let's start with indexing. It lists the last 10 posts. Let's update one. It feels like API, right? It just looks like a normal post, normal form, normal Rails form and API. But in fact, it works over MCP. OK, updated. let's go forward. So here's one of the tools generated from the scaffold. It's a post create tool. You can see all the properties that we defined for active record and some basic logic. It just pretty much runs post new and post save. It handles the basic errors as well. But the most famous application doesn't end here. We should now scaffold comments. So let's do that. Again, we just run Rails, generate scaffold. And a comment references a post and has some content. Yeah. Just like before, the tools are generated alongside the model. Once we run migrations, we can also run the same rake task with MCP tools. Now you can see both tools for posts and for comments. Again, for every CRUD action. We can review some of the created scaffolded tools. But you can see this one is for creating a comment. You can see post ID, because to create a comment, we need this post ID. So this scaffolding works in here as well. And for listing comments, we can provide post ID property to filter by a comment, which might come in handy for the later usage. And the last but not least, showing a single comment. Sorry, you just need to provide an ID, and you can run it. Now, hotwire wasn't in the original application, but, well, there was no hotwire at all back then. But I want to show it through hotwire so that you can see the power that you can get in production as well. So what I'll do is I'll put at the post index endpoint, I'll just change it, and I'll add a post stream. It's going to be fast forward. And I'll create a single partial to list all the posts with all the comments in one partial, one view. I'll just make sure post has comments, and I will make sure that whenever a post changes, it will be broadcasted to the post stream. And I want to make sure that post updates when a comment updates, and I exposed all the posts with comments at the route, at the main route. And that's it. Added hotwire quickly, we'll use it later on. So now it's time to use our MCP server with an LLM host, with an LLM application. There are many LLMs applications that we can use, and there are many LLMs applications with many MCP hosts that could connect to a local host server. But those are mostly developer tools, like Claude Code, like Cursor, or maybe not developer tool, but a more niche tool like Goose, for example. Maybe some of you use that. But I wanted to show you the production value, this element of showing this to your mom, and so that she can say it's great, right? Not a developer tool. So I've chosen Claude Desktop. However, to run our server in Claude Desktop, we need a public URL, and we need a secure connection. That would be a problem if we didn't have Rails, right? So a quick deployment. All I've done, updated the deploy YAML. I already had a domain, which is my wedding anniversary, and a VM at DigitalOcean. I just updated Camel configuration. This is all of it. And pushed my change to GitHub and run Camel setup. Within seconds, well, barely minutes, it's deployed to production, and now it's showtime. So this is our page in production. I open Claude Desktop, and I ask it to write a post. This time about a weird animal, and of course it does. And not through the MCP server, because we haven't connected that yet. So let's do it right now. We open configuration, we go to manage connectors, and we add a custom one. So we put it as blog, we put the address, /MCP, of course, and now it's connected. We can see all the tools that we've created so far. Let's ask it again. This time, create 3 short posts about interesting animals. Now you can see it actually runs one of our tools. Here it is. We have a first post about an octopus. The second, about an eye, whatever that could be. Should be interesting. And about a shrimp. This is real time, so it's one-to-one real time. Just pre-recorded. Let's comment on the post, but let's make it a bit more difficult. Let's comment on 2 posts at the same time. So let's comment on the post about the octopus and about the shrimp. Again, it uses the tool that we've provided. And here we have it. Here we have it as well. As no one knows what II is, let's delete this post. You can see that it remembers which post it is, because once it was created, the LLM remembers the idea of that, well, through the protocol. And let's update one of the comment. Let's make it more intense, or how I call it, LinkedIn ready. Yeah. Here it is. All right. So guys, that's how you turn your Rails server into MCP1 in 5 minutes. But should MCP tools be CRUD? Well, no. But actually, the magic of Rails began with CRUD to reach IPO-ready applications. Let's allow ourselves to go through that same path. Let's learn MCP through simple tools so we can later on model a bigger, more complex functionality. So the tools in general shouldn't be CRUD only. You should actually aggregate bigger functionalities into tools when you want to build more complex systems. But let's start with CRUD and learn as we go. However, if you reach this point where you actually want to build your own bigger tools, allow me to show how it's done. So we have yet another generator, a generic one called MCP tool generator. We just write Rails G MCP tool, check weather tool. We can also provide parameters because tools can have parameters, and that's it. We get a single file. This is how it looks, one-to-one, generated from the scaffold. All we need to do is put our logic. In here, I'm using an API, so I get the weather from third-party service. All right, let's see it in action. I've deployed it again, so now it's available for the Claude Desktop as well. And let's write one more post. This time, let's compare the weather at 2 Rails World venues, in Amsterdam and in Toronto. So what it does, at first, it asks for the weather, the current weather in Amsterdam. As next step, of course, checks the weather in Toronto, Canada, and now we write the post. It's still going. Here we have it, the tale of 2 cities. And we are ready. We generated application, scaffolded models and tools, deployed with Kamal, and used a customer-facing application, Claude Code. So why is it so easy? I'd say it's about flexibility of Ruby on Rails, and thanks to the giants of the community, so open source software maintainers. I couldn't thank enough the creator of FastMCP, ActionMCP, and RubyMCP client as well. I've spent hours, if not days, talking to them so that they taught me what MCP is and how it interacts with Ruby and Rails. And of course, the official Ruby SDK is maintained by yet another team. And this is, in fact, the official MCP Ruby SDK is what powers the template that I've showed you. So big thanks to them as well. So what's next? Of course, we are just playing around with a blog application, but what comes next is authorization. MCP says use OAuth, but, well, rolling out OAuth is something for the entire application, not for a template of MCP. And of course, there are many different primitives. I also told you about resources and prompts, but there are more, like completions or sampling and more. But I leave it as an exercise to you to add to Rails. I promise it's going to be fun. Before I end, I have probably a confession to make, because I promised a presentation about MCP. But how I see this presentation, it's not really about MCP, but it's about the Rails framework itself. Because Rails is ready for AI by default. All it took was adding a single gem and a single template, which isn't that big, and we are kind of by design ready for AI. And no matter whether it's MCP or any other protocol, just with a bit of creativity, you can put it in Rails and make it as easy as you've just seen. Because with Rails, we have all the tools that we need. Just stay creative, please. It's more fun to be creative. Thank you.